In this video, we will be looking at today's LeetCode daily challenge problem, power of 4. This is an easy problem, but there are multiple methods and a great learning to this problem. So let's look what exactly this problem says. So given an integer n, we have to return true if it is a power of 4, otherwise return false. Given this integer like n equal to 16, which can be expressed as which, can be expressed as n is equal to 16 and which can be expressed as 4 square, which is true, and n equal to 5, which cannot be expressed as a power of 4, so it is false. N is equal to 1, which can be expressed as 4 power 0, which is again true. And we are given the constraints like 2 to the power of minus 31 to 2 to the power of 31 minus 1. So this is the range of n. So first step would be, if we get any negative value n less than or equal to 0, just to return false. Okay, and then next comes like how to handle this problem. So earlier we have solved a problem called as power of 2, where we were trying to see like if there exists only one bit in the binary representation of that number. So here also what we have to do, we have to use that problem and we have to keep additional checks. How it could be like, let's see what are the numbers: 4 power 0, 4 power 1, 4 power 2, 4 power 3. Okay, 4 power 0 is 1, 4 power 1 is like 1 0 0. So this is like 2 power 0, 2 power 1 position, 2 power 2 position, and 2 power 3, 2 power 4, like that we can go. So now what happens is, this is the 4 square, which is 16. So this is nothing but 2 power 4. We have to keep 1 here and followed by 4 zeros. So, and if you go for 2 power 4 power 3, which is 2 power 6, 1 followed by 6 zeros we have to keep. And this. So this is how we represent the binary representation of this number. And we observe an interesting characteristic is like there are even number of zeros here. You can see here there are even number of zeros. Okay, so the simplest method that comes to my mind is like uh, just check if there is a single digit one. Okay, first how we can check it, and with n minus 1, this will ensure, this logic will ensure like there is only one in the number, and followed by that what we have to do is equal to 0, and and the logic goes like we have to check if the number is in the even bit position is true, which means like the even bit position, the 2 power 2, 2 power 4, if these are 1, then only we can say that it is a power of 1. So we will write a loop and we will check left shift 1 with I, and where I will be ranging from 0 to 30 only, and I every time we will increment I with I plus 2. This will ensure, this logic will ensure like we are always having whether we always get a number, so, and that is like even bit position is 1. So once we do this, for example, we'll take n 4, n equal to 4. So what happens is I is equal to 2. So I is equal to 2, we'll get it something like this, and once we do a AND operation onto it, so we get like 1 0 0. So it should not be equal to 0, or else we can say like it should be equal to n itself. Okay, so let's see the code for this. This is the first method. So as I have explained, n equal to 0, any negative number minus 5, 4, that will get false here. and then when I equal to 0 to n I less than or equal to 30, and every time we are incrementing it by 2. And this logic will ensure like we have only one in the binary representation, and this logic will ensure like uh, there is a binary representation and odd bit or the even bit position is um 1. So in this will ensure like there is only one. So for example, we have this value which is 2. Now 2 is not a power of 4. So this will ensure. And once we do even bit position, either we will go here and we will do AND operation. This will be equal to 0. Or what happens is we will shift towards the next bit position. Here we will do the AND operation, which is I is equal to 2. So what happens here? Here if we do AND operation, it will turn to be 0. So this condition ensures like to check whether the single bit exists, whichever single bit exists, that exists at the even position. So this is one logic. Now let's move to the next method. The next method is from C++20. C++20 standard library functions. So let me open the page of reference, CPP reference page. This is a CPP reference page. In this page, we are seeing like this bit manipulation, and here are four interesting functions for us. So this is like count consecutive zeros starting from the MSB. So what do they mean by that? Is to say consecutive from say some representation is there, 32-bit representation is there, and one we have 0 here, some zeros are there, here also some zeros are there. So one function will tell like how many zeros are there from the left. MSB means this is the most significant bit, this is the least significant bit, how many zeros are there in this bit position. And there is another function which tells like how many ones are there in this function from left. And there is another function like how many uh, how many zeros, how many ones, how many zeros are there from the right, how many ones are there from the right, consecutive ones are there from the right. These are some of the bit manipulation which comes from C++20, which could be helpful in our case. So in our case, what happens is we have four which can be represented as 1 0 0, and we have 16 which can be represented as 1 0 0 0 0, and 64 which can be represented as 1 0 0 0 0 0 0. So like that if we can use this function which tells like count um, uh, right 0, how many zeros are there from the right, this function. So the how many, sorry, this one. So the count R0, which means count the number of consecutive zeros starting from the least significant bit. So if we use this function and check like whether there are even number of zeros or not, then we can easily tell like if it is a power of 4 or not. So first we will check whether there exists a single zero n and n minus 1, okay, and followed by what we'll do is we will use that function count r underscore 0, which tells like from right side how many zeros are there. We'll give, and that should be divisible by 2. Then we can say like there are even number of zeros. So for this 4 power, or every time we'll have an even number of zeros. So this will ensure us like it is a power of 4. So there is, here is the code snippet for this problem, for this solution. So here you can see n equal to 0 as usual. If it is negative and 0, we return false. With this condition ensures like we have a like positive number, and this count R0, this will ensure we are checking whether there exists a even number of zeros or not. From right, how many zeros are there, and if those zeros are even or not, we are checking it. If it is even, then we return true, else we return false. So that's it for this video. Thank you.